Welcome, ladies and gentlemen. This is Mr. Callen here, helping you with Unit 2, Lesson 8, Pizza Delivery. Go ahead and make sure your textbook is open to page 119. And before we continue on with the textbook, I want you to look at these two problems. I want you to look at how they're similar, look at how they're different. Go ahead and think about that for a moment. Pause your video, come back in 1 minute. So interesting that they both have the same exact terms. They both have a 42, they both have an unknown y value, and they both have a 12. On the other hand, I think you already can see the biggest difference, and that would be the equality versus inequality symbol. And what does that mean? If you take a look on the left side, y equals, y must be. On a graph, you can see negative 30 is displayed as the one and only one solution. On the other hand, so what I'm trying to say is the only number that will work, that will make a true statement, is if you substitute in 30. On the other hand, this over here has infinitely many. And what I mean by that is, I should have said negative 30, excuse me. If you try 0, 42 plus 0 is 0, and yes, 42 is greater than 12. If you tried 10, 52 is greater than 12. Again, correct. If you try 10,000, 10,042 is greater than 12. And you'll notice on the graph, we don't just have one dot. We don't just have two dots. Instead of drawing a billion dots, we actually shade in a solution region. Furthermore, and then I'll just mention that there are infinitely many solutions to this. One last thing to note, where over on the left side we have a nice solid dot because negative 30 is a solution. On the right side, if you substituted a negative 30 and you asked yourself true or false, 12 is greater than itself? No, that's a false statement. So we cannot color in negative 30. Continue thinking about that as we get into our lesson. I'm going to skip that because that's not true. Focus for today is going to be on equations versus inequalities, the symbols that go in there, and the constraints. What is that word? What does it mean? What constraints do we have in our life? All right, so let's go ahead now to page, I didn't write the page here. It's going to be page 120. I want you to pause the video, and I want you to take 2, 3, 4 minutes. Try to do numbers 2, 3, and 4. Come on back when you are ready. All right, so you should have taken a couple minutes, tried to complete numbers 2, 3, and 4. Here's what we got. And of course, you're marking up your text. 15 minutes just to prepare an order, 3 minutes to drive each mile. How long would it take to deliver each? So what I'm seeing here is if I were to start 15 minutes just to make the pizza, and then 3 minutes and another 3 minutes, well, how many 3 minutes do we have? 3 minutes for each mile. And so 15, in addition to the 6 minutes of driving, would leave us with 21 minutes. Let me do the next one. Still having 15, still having several threes. In fact, it's not just an unknown number of 3-minute miles. We have 4 minutes for each of those 3 miles. So 15 plus 12 is going to be 27 minutes to make that delivery. And last but not least, you can follow along with the pattern. Each of those 8 miles is going to be 3 minutes. That's 24 minutes of driving. Don't forget the initial amount of time for a final total of 39 minutes. Now those are expressions, ladies and gentlemen, not equations. We don't have it equal to something, not inequalities. Those are expressions. And in fact, number 5 also is asking us to write an expression. For the number of minutes it would take to deliver a pizza X miles away. Now, just look at the kind of patterns that we see here. We should still have a 15. Not only that, we have 6 minutes, we have 12 minutes, we have 3 times 8. What is that about? So think about what those pieces are. we still have the 15 minutes. In addition to the 15 minutes, we had 3 sets of 2, or 6. We had 3 sets of 4, or 12. For each of those 8 miles, it's 3 minutes. So in that case, we're going to have 3 sets of x. And here's our expression: 15 minutes for the original making of the order, 3 minutes per x mile away for the delivery time. Now with that in mind, wants to deliver orders in 30 minutes. Oh, look at those words, 30 minutes or less. Which inequality represents that situation? Now I want you to think about 30 minutes or less. Would it be okay if it only took 24 minutes? Yes. Would it be okay if it only took 20 minutes? Yes. Would it be okay if it took 1 minute and a half? Yes. Would it be okay if it took 32 minutes? That would make us unhappy. That would make the customers unhappy. So what we need is we need a number at 30 or smaller. Which of those symbols is going to make 30 or smaller? And I think you probably already identified. We don't want 30 or bigger. We don't want 30. We don't want more than 30. And this one is almost there, but that's only 30, only less than 30. We need to have choice A, which will include 30 exactly and would include every quantity less than that. So 15 plus 3x less than or equal to 30. Let's go ahead now and show or describe all the distances. What I'm going to do is I'm going to take, whoa, hello. I'm going to take the inequality statement and let's go ahead and solve for x. So firstly, get rid of the 15 minutes. That has nothing to do with the delivery time. That has to do with making the pizza. That leaves us 15 minutes remaining just to deliver it. Now, if you split each of those into 3, please notice this does not say equals 5 minutes. If it were equal, the only time we would have is there. It said 30 minutes or less. So the real symbol should be 5 or less. That includes 4 miles. That includes 3.5. That includes 2.6. That includes 2/3. So really, when we're drawing the answer to this statement, we would draw a solid dot at 5, and we would, instead of drawing a billion dots, we would draw a solution region to the left. Now, some of you might be saying, but Mr. Cowan, you can't deliver something for negative miles. You're absolutely right. She wouldn't really include that. But I'm just going to pause right there. Sorry about the announcement, if you can hear that. All right, so let's go on to the next page. This will be page 121. Again, I would encourage you to go ahead and pause the video. Try to work out problems 5, 6, 7, and come back to me when you're ready. All right, so you should have paused and thought your way through this. We got 2 possibilities of figuring out all the distances. Mariana here likes the table method. Meanwhile, Camilla likes to make an equation. Now, everything in life has advantages and disadvantages. We know that. What do we like about Mariana's? Well, it shows visually what could be the situation. Now, I noticed she circled 5, but for the record, all of those numbers are also 30 minutes or less, so it includes visually the fact that there's more than one solution. Meanwhile, Mariana's doesn't really show more than one solution. On the other hand, it does show the algebra steps, which we're used to. Take 15 away from both sides, keep it fair, keep it balanced. She doesn't show her divide by 3, but she does do that. We just don't really see the fact that this is an inequality statement. But everything in life got advantages and disadvantages. Meanwhile, large pizza, $12. Toppings are $2 each. She can spend as much as, wait a second, I'm going to put a little question mark that, $20. Okay, so think about 20, think about a number higher, think about a number lower, okay? Which one is going to be okay for her to spend as much as? Well, that means she can spend $20. She can spend less than that, but she cannot spend more than that. So when I see the word add as much as, I'm thinking less than or I'm thinking equal to. So $12, $2 for each topping. You could include T, but they used X. Which of those has the less than or equal to symbol? Going to be choice D. Show or describe all the numbers x that make this true. Let's go ahead off to the side. Let's take away 12 from both sides. You can make a table if you wish. I'm going to go ahead and continue on with this. Split it into $2 increments, and lo and behold, we can have 4 or fewer. Let's try that again. Uh-oh. Just went back on my page. 4 or fewer toppings. And then we get to this word constraint. Now, I do believe we've talked about this. Keyword being limitation. Some examples of constraints. I'm seeing time right there. I'm seeing $20 on a pizza as much as Desmos wants to sell more than 50 pizzas per day. Constraints in your life. We've talked about time. We've talked about parents and or rules. We've talked about constraints with driving, speed limits, age limits just to be able to drive in the first place. Constraints just limit you in your options. So think about that. Let's go on to the next page and wrap up with page 122 and 123. So go ahead, take a moment, 122 to 123. Take a moment and dig into problems 8 through 11. Come back when you're ready. All right, so you should have worked on numbers 8 through 11. Constraints that Jameer might have to think about when planning this party. Well, first of all, I noticed that everything's about money. And if he only has so much money, he can only invite so many people or pick a certain room. Speaking of, the size of the room is a constraint. That might constrain the number of people that can go. The number of people that go to the party is a constraint. And of course, time. If time is included, sorry about my screen. So there's all sorts of constraints. You might have thought of some more. We're supposed to match each constraint to its given inequality. So I'm going to go down, I'm just going to mark the text first. Mariana's party in the small room, okay, that's important, costs at most $140. Now I'm thinking at most means she can spend $140. She can spend less than $140, but she cannot spend more. So at most is going to be one of the greater than or equal to's. And in this particular case, we notice that the small room was $30 per hour with an $80 flat fee, starting with 80, 30 per hour. I'm going to squeeze in a little X. And so we have now eliminated that middle option. Let's keep on going. Owner wants to earn at least $140. They're trying to make a profit on the large room. Now, at least means it can be $140 exactly, so it's got the or equal, and it can be more than. They can make $200. The owner wants to make that profit. So the large room had a $50 per hour, not forgetting the original $80 flat fee. There goes that one. Last but not least, spend up to $140. Again, what I see is I can spend $140 and I can spend $120, but I cannot spend even $141. So it can be $140 exactly. It can be less than both big and small rooms. That's interesting. So we have the $80 flat fee, and then we have 50 and 30, $80 per hour. Notice that one of those had no match, and that's okay. On to the next page, please. Jameer can spend as much as $155, as much as $155 in a large room. Write the inequality. So, large room, $80 flat fee, $50 per hour. As much as $155. What's that going to mean? That means he can spend less than $155. He can spend exactly $155, but he cannot spend more than that. There's your inequality. Let's go ahead now and solve that guy. 80 plus 50x less than or equal to 155. I'm going to go ahead and not use the table method, but if you want, you could use a table method where y or c could be the cost, and then find all the numbers that would be less than 155. The rest of us, let's go ahead and take away $80. That leaves 75. Split it up into $50 for each hour. And interestingly enough, this could reduce. You could write it as 3/2. You could write it as 1.5. You can write it as a decimal. But again, the answer is not just C. We can go for an hour and a half. We could also go for less than that. 1 hour, 75 hundredths of an hour, 3/4. Meanwhile, if you put in 2 and 25 hundredths hours, it's not going to work. It's going to be more than $155. We run into that constraint. The money limits us. We only had so much budgeted. Now, if you need, pause the video, go back, rewatch a certain part of it, but then go ahead and mark up, write in a couple notes. What's the most important thing? What does a constraint mean? How can we write constraints using inequality symbols? And what verb words or word phrases can help us determine which inequalities to use? Hopefully that helps you, ladies and gents. Take care, do well. Let's grow. I'll see you soon.